Mr. Minnick here, doing a walkthrough of MouseEventsDemo1, a Java program that shows students how to handle users' events. So overall, we have a class that extends JFrame, child class that extends this parent class, and we're implementing MouseListener. Now that's an interface, and MouseListener, if you look it up in the API, requires you to implement the mouse clicked method and therefore type something into its body. Have it in your class typed out and something interesting in its curly braces preferably. And you also must have an implementation for mouse pressed, mouse released, mouse entered, and mouse exited. Now I'm choosing not to put anything interesting in those methods, but these headers and sets of curly braces have to be here. So there is a difference between mouse released, when the actual clicker button is let go, versus when it is first initially pressed, if somebody like held it down. That code would happen, that might be typed out there. This code would then, like a grenade going off after the pin's been released, as opposed to when the pin's still in that hand grenade, whatever. Mouse entered, mouse exited is like whether it enters a certain clipping area or the mouse is moved out of a certain area. So where the mouse's cursor is has something to do with those two methods, which I'm not implementing here, so it's not that exciting. Okay, so in this class that does implement the MouseListener interface, looks like in the constructor, I am adding the MouseListener to the class. If I didn't have this crucial line of code in the default constructor, you could try to handle these mouse clicked events and know, for example, when an X deserves to be placed on the screen in a tic-tac-toe game versus when an O deserves to be shown, if it's player 2's turn versus player 1's turn. But none of it will actually execute if you don't have add mouse listener parentheses this in play, so to speak. Now I also have these other class module level variables. Square, I have 2 of the 9 squares implemented in this assignment, in this demo. If you, you'll see here in a second, let's run the program. I'm going to right click, do a run file. In this demo program, only the top left corner of the screen, this is clipped for some reason, you can look into that, but only this spot, which I call that intersection row 1, column 1, and this one right here, row 1, column 2. The other ones, if you see my clicks, aren't working, the other locations of the tic-tac-toe board. So I do have 2 variables that are keeping track of what letter, X or O, are in those 2 out of the 9 squares. See, row 1, column 1, row 1, column 2. Okay, then I needed an XY to keep track of the horizontalness of the mouse click and the up and downness, the Y position. Okay, let's proceed. After initializing those 2 square-related variables to empty string, because they're neither X or O so far, and player turn 1, that must be X. X is considered player turn 1, and I'm assuming if we trace the code further, player 2, the O guy, is probably player turn either 0 or maybe 2, player turn 2. Oh, right here. I use -1 for some reason if it's O's turn. You'll see why later, when I don't use like the number 2 itself. Okay, the paint method. The paint method, let's shrink all my methods here, especially these ones that have no implementation and no real role in this program. Okay, every time that something happens, the screen gets refreshed and the paint is called. Particularly when the mouse is clicked, at the end of mouse clicked, I call repaint, which is really calling paint. Even though they're not named the same, it's the way Java graphics work. So this method right here, paint, is like where all the action, pretty much the main action takes place as far as drawing stuff on the screen. Obviously, these are some of the lines of the tic-tac-toe board. You should have, I should have labeled this like top horizontal line or something. I did not. That would be something we would do in an assignment if you turn something like this in as an assignment. Look up the draw line method. We learned that in an earlier lesson. The draw line method from the graphics class, which was imported here from Abstract Windowing Toolkit. Okay, so that sets up your board. Hopefully it doesn't flicker. Let's watch. I'm going to run the program, but those lines are being redrawn each time I click. So watch. Let's see if the top horizontal line or so flickers here when I click and put my X up here. Yeah, totally flickered. Oh my, it's like redrawing the whole screen. If you can find a way to buffer and prevent that, please do. Hint, there's most likely a way to do that. This demo isn't giving you that feature. Okay, now each time that the screen repaints itself, we're checking to see if square 1, 1, which is the top left corner, if that variable currently equals the string X in double quotes. We don't use a double equals here because strings are, you can't compare them with double equals. You know that. So this right here puts an X. Two diagonal lines are being drawn here by these two draw lines. Now square 1, 1 can't be both an X and a 0 at the same time, so I should have used else if here for tighter logic. This draws the oval if square 1, 1 equals an O. So these variables here are like the brain cells that are keeping track of what player currently logically occupies 2 of the 9 squares in the board. It's this layer of logic, like your brain. Then there's the expression of your face. They should be consistent. If you're happy, you should have a smile on your face. Sometimes they're not, and that's bad logic, and therefore you lose points, but nobody want to play your game. Let's see here. What else is going on? So basically, now square 1, 2 is mutually independent of square 1, 1, so I cannot put an else if here. That needs to be its own like little if. Maybe put an extra blank line in there for organization, and that probably can be an else if. I'll just say it. And so there'd be a lot of work to do here for the other 7 squares. To do, on your little to-do list, implement the other 7 positions on the tic-tac-toe board. Now, when the mouse is clicked, at the moment the user creates that event called a mouse click, a mouse event. It comes in from the sort of keyboard or from the mouse as in it comes in as E. And there's this in the mouse event class, there's a getX method that just figures out where horizontally the mouse was clicked. And really, yeah, it's the motion, it's where it is currently positioned. It's not even a click, it's just where it is currently at. And I'm storing it in this variable called X. And really, it probably could be local. I don't see X being used anywhere else. Yeah, how about that? So really, I'm guessing these 2 variables, I'm going to do a little comment out here. And now you would not put the word private if they're local. You just throw int there in front. Let's just make this program a little bit meaner and re-execute it and see if it works with local X and Y rather than, oh yeah, it still works. Look at that. How about that? So keeping it that way, now it's all just logic, geometric logic. If the X event, the mouse click, occurred less than 50 and the Y was less than 50, because of the I planned this out in graph paper. I'm just not showing you the graph paper, but I should have. Apparently, this is the position X equals 50, and this is the position Y equals 50. Because remember the Y-axis, Y starts at 0 up here. If you read the lecture notes or know anything about the graphics window, and y goes increasing as you go down the y-axis. That's the way it is in most computer languages, graphic environments. So then I have a nested if-else if statement inside the if. So if the click is in the upper left corner, if it's player turn 1, I know to create that brain cell and store an X there. You can't paint stuff in the mouse click method. You can't invoke G dot methods that we studied earlier. Because G is a graphics object, it's only available in the paint method. So this is like the brain, this mouse click. But when we get down here a microsecond later and call repaint, then all the logic is built in to the fact, oh, I over-indented there. It's all built in to the fact that I'm using this layer of variables. I'm calling them the brain cells, square 1 and 2, square 1, 2, the variable square 1, 1. But it's all kind of like works consistently together. And if I do give an assignment this semester that you're watching this video called like game project, it's your job to plan this out and think of all the private class level data members that you would need, and then any local variables that you need, like I have X and Y here as local variables, and how complicated you want your game logic to be, because the interface has got to match the brain, the facial expression, as I say. Okay, right here, this if statement that handles the upper left corner, square 1, 1, we call it. Square 1, 2 is being handled here by this logic. It's kind of brute force, redundant, copy-pastable. Then look at this. After the first player goes, the variable player turn that was equal to 1, meaning it was X's turn, I multiply it by -1. It's like a toggle on-off switch, like the light switch that right now in this classroom I'm turning off and on. Turning off and on a light switch is really just multiplying -1 against that like little switch thing on the wall. So you can't do that with numbers 1 and 2 very easily. So I use 0, 1, and -1. It's just like something I picked up somewhere 20 years ago and just do it every once in a while. That's it, except for the main method that gives this guy the ability to run when you right-click over here without a test class being separately involved. This, of course, sets the size of your screen. It makes the screen visible. We studied this. It makes it so that you can close the program by clicking the upper right corner, perhaps, and like any sound that's playing in the background would like close along with that because of some stuff that goes on there. And you just have to instantiate a copy of whatever the name of this class is, Prague. I just named it Prague. Now, if you do want to fix this program so that right now you have a good game of tic-tac-toe going on, but you want the whole top area to not be clicked, figure out where you have to like draw this screen or make it larger and center and all that. Maybe even make it so it resizes. That'd be cool. And try to get that flickering out. I'm not sure how to do that. Look it up. Okay, that's all I have to say about that demo program. So see me in class if you have any other questions.